Welcome to Python Sweden, the workshops track. Now we have the Python Serverless Microservices. Microservices and serverlets are the hot topics in the web development community that, when combined, increase the potential for developers to make software faster and to host it much cheaper than traditional virtual private servers. This talk aims to present a minimal set of tools to start developing serverless microservices using Python. With the serverless framework configured for Python, developing a microservice API becomes very easy. The framework provides a set of tools to pack Python dependencies and also deploys the required infrastructure to the cloud, enabling infrastructure as a code since the start of the project. Although the serverless framework is used during the presentation, no other Python framework is required, making it as easy as possible to start with plain Python code. Author Nilo Coutinho Menezes is a software architect that loves to program in Python and to design new software to run in the cloud. A professional computer programmer since the 90s, he has a bachelor degree and bachelor degree in data processing and master's in informatics computer networks from the Federal University of Amazonas in Brazil. He's an incomplete PhD at the University of Mons, Belgium. Nilo wrote a book about the Python programming for beginners, published in Portuguese and Spanish. He tries to participate in Brazilian Python communities, especially in the north region of Brazil, United States, trying to spread the Python in the Amazon region. So welcome, Nilo. So let's start your presentation.
Hello, good morning, Python Sweden. It's a pleasure to be here, and today we'll be talking about Python Serverless Microservices. This presentation was formatted to be a workshop, so we have lots of code, lots of examples, and I will also talk about very important topics that you need to know when you start developing serverless applications, especially in Python. I'm Nilo Menezes. I'm talking from Belgium. I was born in Brazil and I'm living here since 2006. And I'm a Python programmer, a long-time Python programmer. And I would like to share with you some of the developments I have made with serverless. But let's first present the plan. The idea is a short introduction. It should take about 10, 11 minutes on what is serverless, what are microservices, and the difference between the serverless technology and the framework that shares the same name. It's a little bit tricky, but I have slides just for that. And we will also see 3 examples on how to use serverless and Lambda functions precisely to show how to show the IP and country you're coming from, and also a medium application like a URL shortener. I think it's a very good example of what we can do. In the first example is automatically created by serverless, so it's an easy one. The second one, we will tweak it a little bit, and the third one, we will be even using a table in a serverless database. So let's start. There is the serverless application framework that we usually see in the following slides by just serverless, and it's written in JavaScript, and it's a set of utilities that will allow you to specify your application in a single YAML file, and it works with multiple languages. So even if it's originally written in JavaScript, it's not a problem. You can deploy your code written in Python and in many other languages. But of course, you have to install Node and some JavaScript dependencies to use it. You see, it's straightforward. After you install Node and the 2 npm installs, you are free from JavaScript. It's very good to deploy infrastructure in the cloud. It tries to be cloud provider independent. We will see here in the workshop Amazon Web Service because it's the one I use the most, but you also have features for Google Cloud, Microsoft Azure, and others. It simplifies the configuration of applications, so it's very easy to create new stuff in the cloud, and it also helps a lot when you have to deploy and update the infrastructure you already created. All configuration files are written in YAML format, so it's kind of easy to read and understand. And you can learn more about it in serverless.com. Here, the tricky part. So why serverless? Why this name if the server is still there? Well, we know the server is still there. Usually serverless is used when you don't have to care about the server. So we know it's there, but we don't have to keep it running. The cloud provider will do it for us. We don't have to update it frequently. So the Linux and the operating system that runs your functions will be kept by the cloud provider, not by yourself. So you are immediately free to apply security patches and lots of other stuff that surrounds the operating system. It also provides outscaling. So, for example, when we work with serverless infrastructure, if you have lots of access at the same time, the cloud provider will create more instances automatically for you, and usually you don't have to do anything. Of course, there are special situations where the traffic spikes and the cloud provider may not scale at the speed you need, but there are workarounds to that. But for the common applications where maybe, for example, you can get a post on Slashdot or something like this that will scale fast, you have had a chance to outscale as they planned. And one of the biggest advantages, especially for smaller applications, is that we only pay if you use them. So, for example, if you have an API call that is called 2 or 3 times a day, you don't need to allocate a full server to run it. You just say, okay, if this is called, you will execute this code. I will pay by the call, the memory used, and the runtime. And usually you are billed in fractions of seconds. In AWS, it's 100 milliseconds minimum. So serverless is an industry term to say somebody else is taking care of the server for you. The server is still there, and that's the main difference. So I'm using a space between the word to make it different from the framework itself. Okay, and what about microservices? Microservices are an architecture for development and deployment of new systems. It's a concept that is gaining a lot of strength in the last years. I think since 2015, it's getting stronger and stronger. Why? Because it's easier to, in certain circumstances, it's easier to deploy smaller applications instead of the big monolithic architecture that we are used to work. For example, when you deploy something written in Django, it's very well adapted to the new cloud technologies, and it's a good way to split a big system in smaller ones, especially if you work in a big company and you have different functionalities of your system being developed by different divisions or sectors, or even different teams in the same place. It's very easy because the teams just have to agree on the API they're gonna use, and then each team can deploy the instance of the microservices, and they share the code only using these APIs. So each team is able, for example, to use their own database, to use different databases depending on the application and the problem they are solving, and they are also free to change everything behind the API. So they can, for example, decide that certain parts of that system will be implemented in different programming languages. There is no commitment beyond the API that they agreed before. So this is very attractive, especially for larger projects. There are very big companies already adopting this concept, like Netflix. I think it's the biggest showcase now. And one of the concepts is that you don't share the database with other microservices. So each microservice has its own database. All sharing is done by a common and agreed API. If you need to change the API, you need to agree with the other partners that, okay, I will deploy a new version of the API. And it's a microservice, so it should be small. And the idea is that it can be rewritten completely if you need so. Lambdas. So we'll talk a lot about Lambda functions. So Lambda is the name given by Amazon Web Services when you have what is now called as function as a service, FaaS, and it means that you deploy a function and you pay for the function runtime. It's the serverless concept, but the product on a AWS cloud is called Lambda, a Lambda function. You need to have an AWS account to use the code that you present. They give 1 year for free, so it should not be very hard to create your trial account, and I don't think we'll do anything that you break the bank or go beyond what they give for free during 1 year. Okay. If it's your first time in AWS, please go there, check the web page. The creation of the account is usually straightforward. They may ask your credit card, so pay attention. And to start using AWS with Python, we simply need to install the command line client. It's pip install AWS CLI. But you need the account, because when you have the account, you create a user. The user has some security credentials. There are different forms of credentials, but they have this all explained on the website. So when you join, you get all this information. If you already have an account, you are ready to go, just install the AWS CLI. If you need to learn more about microservices, I recommend these 4 books. The second one is an update of the first, the same author, Sam Newman. Sam Newman is one of the main authors that coined the term microservices, and it's based on principles defining in domain-driven design. So some of you may already have read the book of Eric Evans. It's still very, very useful today. And after that, you can also read Implementing Domain-Driven Design by Vernon. It's also a very good book, but I recommend reading the Blue Book first. Okay. So let's start with some code. We already started the AWS client. So the most difficult part of this workshop is to install Node.js. The procedure changes a little bit if you are using Windows or Linux, and it's a different procedure for each Linux distribution. So in some distributions, it's not even available for installing the package manager. But luckily, the guys at nodejs.org have special instructions on how to set up this for each distribution. So just visit the web page, find your operating system, and install what they required. On Windows, it's easy. You go there, they have a setup. But on Linux, it may be a little bit tricky. It's the first time I see this in my life, that it's easier to install on Windows than on Linux, but they made it. And after you install the Node.js in your machine, Node also install npm. npm is the Node package manager, and we are going to use it to install the serverless framework. So here I'm presenting the globals install. If you wish, you can install in a separate instance. It's up to you, but usually we install it globally. So it's npm install -g serverless. It takes a while to download lots of dependencies. After all, it's a JavaScript framework. It's never a standalone, but it's fully automatic. Once it's installed, you can simply type serverless in the command prompt, and the framework will create a stub application with the configuration files needed to deploy it. So I try to put my screen when I created the application for this workshop. So it's a very simple set of questions that you just ask. Okay, do you want to create a new project? Just answer yes. What do you want to make? Just select AWS Python and the name of the project. In my case, I put PyCon SE 2020. And then it starts creating a new folder with lots of files inside. The creation is straightforward. Of course, they will offer the commercial service. You can simply say no. And that's it. You created a simple project using serverless. Okay. The step application automatically created for you is created in a file named handler.py. I ask you to please rename it to hello.py, simply to make it clear, because we will see at least 3 different handlers, and to have a file named handler.py may be confusing. So what I did is I got this Python file created for me. You can see that it's really a function. We are just importing JSON and defining a very simple Python function with event and context as parameters. We'll talk more about them later. And I'm creating a dictionary that returns a response. The response simply prints the body that will show everything, every header this function received in JSON format as an output. Okay, and as any function, we just return the dictionary we created, and that's it. You have a serverless function. Let's see how it goes from here. Besides the handle.py that you're gonna rename to hello.py, the serverless command will also create the serverless YAML file. This is the configuration file that will create the Lambda functions in AWS. So this file is very big because it's full of comments. So I stripped down the comments here, but it's very useful if you take some time to read the comments. They explain every single option. But of course, they would be too big to show in a single slide. So I removed the comments, and in the end, you have something like this, where we have the name of the service, it's PyCon SE 2020, the framework version, the provider I'm selecting here to use AWS, the runtime I'm using Python 3.8 because this is the version I use in my day job, and the region I choose Ireland because Ireland is, I think, the cheapest region in Europe. So I think you also have a new data center in Sweden, but I think it's a little bit more expensive than Ireland. So if you are in Europe, I strongly suggest you use West 1 unless you really have strong latencies issues. And we have here the configuration of the API gateway. We'll see where the API gateway is in this architecture later on. And we also have the functions. Here is where I define the Lambda function itself. You have the functions, and then I create a hello function, and I specify the handler. The handler is the name of the Python, so that's why I asked it to rename handler to hello.py, dot the name of the function. This is the same convention used in Django applications. So if you ever use a Django, when you have to specify a function inside a module, usually you write in this format. So it's the same convention. So Python file, the module dot the function, and I say link this function to this event. So if I access HTTP method with PyCon SE/hello using the HTTP method get, it will call this function for me. Okay, so with all this information, serverless know that it has to create a Lambda function for you. It will link to this endpoint PyCon SE 2020/hello, and it will deploy using Python 3.8 in Ireland using your AWS credentials. Okay, so this is all the configuration we need to do this. It's a lot of work. If you have to do this manually, you would have to create the function using the console. You would have to go to the API gateway, create a new deployment, create the bindings between the endpoint and the Lambda function. It's a lot of work automatically done for you if you use this framework. So I strongly recommend you to use the serverless framework. I'm using Python 3.8, but you can also use Python 3.6, 3.7, and Python 2.7 if you're still using it. And it's straightforward. So if you need to change the Python version, just change the runtime version. This is enough to deploy. So if you just type SLS deploy, it will use your AWS credentials. Mine here are in black, just to hide it, my account number, but it's not a problem. So what does it do? As soon as you type SLS deploy, it will gather the configuration files and you start building the package. In fact, it creates a zip file that will be uploaded to S3. S3 is a file storage on AWS. It's not important now because it's handled by the serverless framework. So with this command, we will do all these steps. So it will deploy to S3, and then it will create a stack. A stack is a configuration set that you create in your cloud provider that says, I need this infrastructure. This is where the infrastructure as a service enters. We talked about function as a service, but here we are also creating infrastructure using code. And this is done by us using a stack. In AWS, the service that creates stacks is called Cloud Formation. But you don't have to care about this because serverless automatically creates the stack using the Cloud Formation syntax for you. So here we are just deploying. We are using lots of AWS services that we don't really need to know. It takes a while, so less than 1 minute. I think in half a minute it should be done. And then it displays the service information where you have the name of the service, the staging, because you can have a staging for your developing code and another one for production, quality assurance, and so on and so on. The region you deployed, the name of the stack. So the name of the stack is the service, and they use the stage as a suffix. The number of resources I deployed, here it's 34 because I deployed the full example. So we have the 3 examples in this workshop deployed in a single serverless file. But if you do step by step, you should have less than that. Okay. It says I'm not using API keys. It's not important now. What's important is that we created endpoints. So the URL you have here will be different in your deployment. This is created in my AWS account. So this is a very big name. You may say, yeah, it's not user-friendly. I agree. But you can customize. So if you have a domain, you can set up your domain and use it here instead. The nicest part is that with these commands, you already have a TLS certificate ready for your function. So a function can be served using secure connection, and you didn't have to handle any TLS setup or anything like this. It was automatically created for you. Here, as I said, I deployed all the functions in the serverless YAML file. So I have 4 Lambda functions created for me and 1 layer that we'll talk later on. Okay, the most important if you are doing this workshop on your computer is to take note of the URL because you need it to test the service in the cloud. Once this is executed, the deployment is done. You can simply visit the address. So you can type this monster URL generated by serverless, or you can use the bit.ly shortcut that I created. I just apologize because I used case, and bit.ly is case sensitive. So you need to type PyCon SE -hello using all these capital letters. If you go there, you should see this super user-friendly page. It's not user-friendly at all, but we will be working to enhance it. So if you remember, when we created the function was very, very simple. It didn't know special handling. It was just returning the JSON it received in the event. So what happens when your function runs in Lambda, the API gateway will collect lots of headers from the caller, from the AWS environment, and they will send it to you in the event. There is a Python dictionary that you can visit and use part of this information. So as you can see, we have lots of information here. We're gonna use the caller's IP and the caller country to write the second example. Okay, but you have lots of information. You know which browser called your function. You have which languages the user is using, if they accept compression, all standard HTTP headers, plus some stuff from CloudFront. CloudFront is another product from Amazon. It's the CDN of Amazon, and they automatically detect, for example, if the client is running a desktop application, a mobile application, a tablet, or a smart TV. So you have different headers that you don't have in a standard application. And if you just copy and paste this to your text editor and ask it to format in proper human readable JSON, you see lots of very useful information here. Okay, so this is our first example. We're gonna work to improve the output of our lambdas, but as you could see, it's very easy to start with the stub application and have something running in the cloud with very simple. I think we didn't write more than 10 lines of code. The hardest part is the initial setup and to get the AWS credentials to create the AWS account. After that, it's just a set of functions that are gonna work. Okay, so in this JSON we have all the parameters passed to a function. If you go back to the function sort code, it's the input field. As I said, you can copy and paste and reformat in JSON using your editor. It will be more readable, and you can extract lots of information here, including the query parameters, if any parameter was passed, as well as path parameters that you see in the third example. And you had access to all of this using simple Python code. It's a Python dictionary. There is no special function being used, and the only module we used from Python was the JSON module so far. Okay, so what do we have now? We have the clients represented here, maybe from mobile phone, from a desktop computer. And we have the Amazon API Gateway. The API Gateway is the product that will translate your HTTP calls into Lambda function calls. Okay, so the client will be using a web browser, as I did here using Chrome. The API Gateway is your web server in the cloud. It will translate this HTTP call in a Lambda function call that is done inside your AWS account. Your Lambda function will return a JSON response that will be translated to the browser for you. Okay, so in between, we talked about Lambda functions, but you have this Amazon API Gateway that you can see as your web server. This is the web server that Serverless created for you. It's also a serverless service, so it's a managed service, so it's kept running by AWS, and you also pay per call. So for example, if you have a very simple application like a Telegram bot or something that receives 100, 200 calls per day, you should not spend more than 1 or 2 euros per month with this service. Okay, it's very cheap, very easy to start. So let's enhance it a little bit. I will get the stub code, but I will create a new one. It's called showip.py. And I will filter the event information to show the IP and the country of the caller in an HTML page. And I will try to format the page to tidy up a little bit to not generate a very ugly output as we did in the first example. So showing your IP and country, you get the headers. To make something beautiful in HTML, I suggest you to use the Jinja 2 library. It's very good. I think it's a lot of people that work with Django already use Jinja 2. You can use the same library. You don't need to use Django for that. So just create a new Python environment if you didn't already do so. And call pip install Jinja 2. It will download and install Jinja with all the requirements. Jinja uses a binary library that is not pure Python. So if you are not using Linux, you have to change the serverless YAML file to say that you need to use Docker. Why? Because the Amazon server that runs your function will be running on Linux. So if you just have Python code as we had in the first example, it's okay. You don't need to do anything. If you are using Windows and you need to deploy binaries to your during the deployment of your serverless code, you need to install Docker, because Docker will be called by serverless, and it will build all binaries on Linux, and they will upload the proper libraries to Linux. Okay, so this is a tricky part. If you never worked with Docker, it's easy install. If you make it work on Windows, the serverless framework will be able to use it and do the deployment automatically for you. You just have to add a line saying Doctorize true. But if you are just starting, I suggest you to install a Linux virtual machine. It's also very easy. Or another solution where you can run Linux and do the deployment. It will be much easier. If you have any problems with that, just contact me. I have a few solutions for that. We also, as we are we started to use external libraries that are not part of the standard Python distribution, like Jinja 2. I have to install a plugin in the serverless framework. So I installed this plugin, typing SLS plugin install -n serverless Python requirements. This is the plugin that you read your requirements.txt file, and it will download using pip in a separate folder, and it will create a zip for you. This is all done by serverless. So our job is just to install the plugin, and of course we have to create the requirements.txt. I created one already for you, and it's on GitHub. And of course, if you are doing this on your own, you have to add Jinja 2 there. So the function that will extract the events is also very small. It fits in this slide. You can see here I'm using Jinja 2 because Jinja 2 has the HTML template. So this is just the boilerplate code that we use to load the template in Jinja. And the serverless part is here. So I get the headers from the event dictionary. And from these headers, I extract the country information. So it's the acronym. As I'm calling from Belgium, you see BE. If you try the function on your side, you probably see the acronym of your country. And in the next line, we also use the headers. I'm extracting the IP of the caller. Here you have two IPs because it's received by the API gateway. So the first IP is the caller IP. So I'm just extracting here it from the string, use simple Python code. So it's a split by comma, and then I get the first element. This is the Jinja template. So I say, okay, give me the show IP HTML. All this HTML file you also find in GitHub. I will give the address in the ending slide. But it's a standard Jinja job. So you just return the status code 200, you create a variable called body, and where you pass the IP and the country information, and you say it's an HTML page, and the integration will automatically transform this into this very good looking web page. You can see I'm not a web designer, but it's much better than the first page. We even have different lines to display information. So this is the case for me. It works on Chrome or any browser. There is nothing special on this. It's a plain HTML page. Okay, so this is the second example. I will try to present the third one. The third one is a little bit more complex. This time we will be implementing a URL shortener service like Bitly, but of course much more modest. This is the kind of service where you enter a big URL, and the service will create a short code that you can use to call that URL, like I did with Bitly and in PyCon SE-hello. Okay, so this service will use two Lambda functions. I will explain them shortly. So first, to really implement a URL shortener, you really need to get a short domain name. If you keep using the URL, I'm using the Lambda function. You see it's very, very big. It will probably be bigger than the URL being shortened. But as I said, you can customize the domain, use it, and make it shorter. So you are not obliged to use this big AWS domain name. The service is simple. It means that we need to get a URL like google.com, and we have to submit this to the service. The service should create a a link with a short code. And if I access this URL with the short code, it will increment the access counter. It will redirect to the final URL. And I implemented it in a way that the entry will be deleted from the database after 2 days. This is just to demonstrate a resource in the serverless database called DynamoDB, where we can delete a record after a specified time to leave. Okay, and of course I don't want to pay for a big database if somebody decides to use this service, but I will keep it running probably until Monday, so you have plenty of time to test after the conference if you need. And of course you have everything you need to deploy in your own account. So what you do, you use the same function to process get and post requests. I will show you how to set up this in serverless. In fact, we just create 2 events. The get call will show a simple form with a field to enter the URL, and the post will process the user input, create a record in the database, and return a page with the links created. Another function will get the code and redirect to the user URL, incrementing the counter. So we could implement the URL shortening in 2 functions. The first thing we need to change is we need to tell serverless that we need to create a table for us. So in Amazon, you have this DynamoDB web server that is kept running by AWS, and you only pay what you use, so that you pay for storage, and you also pay by the number of requests. And to specify that you need a new table in serverless, you just have to put this in the YAML file. So you need to say, I need a new DynamoDB table. This is the name of the table. The key is called short key. Okay, this is the hash key. It's like the primary key in standard relational databases, and the short key it's a string. That's why you have this attribute type. The capital S means it's a string. Okay. As special takeouts, we have here the time to live specification. The field that you determine how long this record should live is in a field called TTL, and it's enabled. So once the TTL is reached, the database will get rid of your record. Okay. This I did to not grow the database in an uncontrolled fashion. So we are using DynamoDB. It's a key value database in AWS. If you never use a key value database, it's very good because you don't pay a lot of money to have an instance. You can also download and run it locally. So they have a big Java application to run this. It's up to you. And it's also very cheap if you want to test on AWS directly. I recommend this route. It's all serverless, pay for storage and requests. It's super fast. It scales automatically. So they are able to do the sharding and now database scaling stuff for you. And it has as drawbacks that it's very odd at the beginning. So if you never work with a NoSQL database, it's a little bit strange. Just a hint, all your application will probably use a single table. So for normalization and relational database guys, it's really frightening. And of course, it does not support SQL. The table in Python, I'm going to use another library called PineappleDB. PineappleDB bridges Python with DynamoDB, so it looks a little bit like a Django model. If you ever work with a Django model, it really looks alike. We just have to say, okay, this class is a database model, and it uses this database table on this AWS region, and then you just specify the keys, the fields, and you say hash key equals true for your key, the database key, the same as we specified in the serverless YAML short key. And I also added 3 other fields, the URL, the counter, and the TTL to make an implementation of the URL shortener service. Okay, so it's quite straightforward. The database operations with Python are very, very easy. So here you have the lines and you have the full source code on GitHub. So this is all you need, for example, to check how many lines with that key you have. So I just check, okay, if the counter is 0, means that the key is unique. I can go ahead. To create the new record, you just create a new instance of the class, you pass the fields in the initialization, and you simply call save, and your data is stored there. To query is also very simple. You just pass the key, and as it's an iterator, you have to call next to get the result of the query. Okay. To update the counter, also another line. So here it's like the update clause in a SQL database. So this is the syntax we use to say, okay, take the value that is in the field and add 1. Okay, this is more reliable than fetching the value and adding 1 in the client side. Let the server do this. This is how we specify. So what did we do? I've shifted the diagram a little bit to the right. So here you have the API gateway. You have the 2 endpoints that we created with the 2 different Lambda functions. So if we call get and post with this URL, it will call the URL shortener create. If you call with the key, it will call the URL shortener.use function. And both are using the Amazon DynamoDB. All this was created by Serverless for us. So how does it look in serverless? Well, I have to create other 2 functions here. You can see the create URL function, the use URL function. The handler is different in the same format as before. So you have the Python module name, URL shortener. And then you have the function inside this file you want to create. Here's .create, here's .use. The rest, I think it's easy to understand. So this is the path and the HTTP method to call this function. And the function has internally to decide which method was used to call it. So there is a shortcode to say, okay, was it a get? Do that. Was it a post? Do the other stuff. You also have to say to serverless to deploy the HTML files with your templates. Remember that we are using HTML pages now. So you do this using package include. The Python file itself is automatically deployed by serverless, so you don't need to specify. But if you have extra files like txt, configuration files, and so on, you need to put here in the include. The role is a permission that you need to set up. It's a big configuration. I added to the serverless YAML the Dynamo URL setup. Basically, it says that Lambda function can create logs and can also access the database for this, and that operations, okay? So this is very AWS specific. I included in the example files, but I don't have a slide to explain because it's really specific to AWS, but you can understand that the role simply is the set of permissions that will be given to your function when it's running. And that's a bit of it. The special gotcha here is that this is the syntax we use to specify that everything you pass after URL / will be a parameter. So it will be called short key, and the framework will insert the short key. We will send the short key as a path parameter into the function. You'll see how to extract it in the code. Okay. And with this parameter, you can see that even if the base URL is the same, here the method changes. Here we have the get as well. But for the second function, we pass the short key. So it's a string match. So if it matches here, it will execute there. But if you pass this parameter, it will match this function. Okay. It's like the URL settings in Django. So if you use a Django, I think you are at home. How does it look? If you call the get method, it will show the simple page. It's a HTML form field where you can type in URL. Once you click submit, you jump to the other page. This is the page written by the post. It will say short URL created. It will display the original URL, and it will also display the short URL that is simply your service appended with the shortcode created during this call. And of course, if you click here, you'll be redirected to google.com. If you want to know how this is done in the code, the full source code is there. Okay, as we are out of time, I will hurry a little bit. But hey, we did all this without a huge framework. So we didn't install anything bigger than the serverless framework. You have to do this once. And for example, I can already generate HTML pages using a template engine using Django. I have my wrapper to the database that's PineappleDB, and you can add the libraries as you need. Okay, it's very important because you can have very easy and straightforward access to your cloud provider resources and services like databases, API gateway, queues, and etc. The advantages are basically the functions are very small. You can read them from top to bottom, so no magic code. Everything is there. You can have millions of calls, millions of invocations for less than €1, so it's really cheap. Pays as you go, so if you don't use, you don't pay. I recommend it for Telegram bots, for example. Functions can be deployed independently, so you don't have to stop your application to update the source code or to deploy more functions. This is done for you by the cloud provider, so you can simply deploy everything, will continue to run. No downtime. But there are also disadvantages. First, it's a little bit difficult at the beginning, especially if you never used the cloud provider before. There is a lot of stuff to learn. If you are already using a cloud provider, the provider probably already know a lot of stuff, so it gets easier, but it's not so easy in the beginning. You may get dependent to the cloud provider because it's so easy to use the cloud provider resources that you can use more and more, even without noticing that you are really bound to the cloud provider. So pay attention. What I do is every time I use something for the cloud provider, I try to think, okay, if I have to go to another cloud provider, can I have it there, or can I use a different implementation that will give me the same results, and how much my code has to be changed to if I need to do this move. Okay, you have to learn how to use a lot of tools, especially in the cloud provider side. Lack of framework can be a little bit difficult, but over time you start building lots of libraries, and it becomes really easy to go. So what's next? I recommend you to add more functions to really build a microservice. You can also play with AWS Cognito that will provide the authentication services. So you can say, okay, I have this API, but you have to log in to have access to it. And using AWS Cognito, you can have, for example, Google and Facebook integrated logins quite easily. You can also read about Lambda layers. You find an example in the configuration file. Basically, it's a zip file with all your requirements that is deployed by the serverless framework and shared by your Lambda function. So instead of putting everything in a big zip, you split the requirements that are usually big, around 7-8 megabytes, and you create a Lambda layer, and you keep your functions very small. Why? Because in the AWS console, you can edit your functions if the zip is smaller than 3 megabytes. So it's very important to keep it slow, especially when you are developing. You have a screen on the AWS console where you can change your Python code. They have a mini HTML IDE that you can use to change and make some tests. It's really nice. If you really want a framework, there are different frameworks. You have Calais, made by Amazon. It's in Python. It's very good. You also have the Sun framework developed as well by Amazon. I never used Sun. I had a very good experience with Calais. And you can also use Django if you use Zappa. Zappa can encapsulate a Django application into a Lambda function. So if you have a lot of Django applications, you can start having a look on Zappa. It's ZAPPA. So I thank you very much for the opportunity to present this workshop. I'm a little bit over time. You have all the source code hosted in GitHub. So this is the URL. The presentation is already on Speaker Deck. So if you go to my Speaker Deck, .com/lskbr, you find all slides there. And if you have any questions, you can find me on Telegram. It's lskbr. This is my nickname since a long time. Or you can simply send my mail. It's nilo@logicraft.be. Okay, thank you very much.
Thank you, Nilo, for the very great workshop. I asked if someone had some questions, and I got the feedback. Everything seems to be quite clear, and I like it as well. Now I know how the Lambda works on the Amazon. I just heard about it. We've been discussing quite some time, and it's quite simple. Thank you very much for your workshop. It was great talk, and reminding everybody for we continue on the workshop track at 2 p.m. Thank you, everybody. Thank you, Nilo.
My pleasure.
See you.